the new picture. Try to do the orthographic projection of that picture. And I am going to explain the procedure to create the isometric when you have the views. You have the views, and we are going to create the isometric. That's okay? Good morning, guys.
Good morning.
Today we are going to talk about the technical drawing and specific about the orthographic projections. We live in 3 dimensions, no? 3 dimensions. But all the information that we have, the papers, is in 2 dimensions. Now, I want to read that paper. That paper is in 2 dimensions. And our life is in 3 dimensions. This is our dimension. Probably other people in other galaxies, they live in 4, 5 dimensions. But in this moment, we are here in 3 dimensions. When you see a picture in a book, this is a representation of one object like this in 2 dimensions. Yeah? It's a representation in the paper of this element. For that reason, you can create the orthographic projections of this element in a paper. And you can see this element in front, that's the front view, or you can see this element on top, that's the top view, or you can see that element in the lateral view, left side or right side. Yeah? Those are the orthographic projection. Is the projection, suppose that you have a light, a beam of light, and this is the projection of this object here. That's the projection of this object. It's like this. Yeah? That's the projection when the light passes over there, that's the projection. This is the front view. What is the lateral view of this? Is when you project the light here, is this rectangle about this, and this is the dot line about that point. Yeah? This is the lateral side, this is the front side, this is the top. Those are the projections, the orthographic projection of an object. I have a question for you. Suppose that I have this marker, and I want to make the 3 projections. I want to draw the 3 projections. This is the top, this is the front, and this is the lateral. About this. Suppose that this is the front view. In the front view, you see what? You see a circle. And we are going to indicate the circle with a center line, indicating that it's a circle. Oh, okay, in front, it's a circle. Okay, what about the top view?
Cylinder.
It's a rectangle, no?
Yes.
It's a rectangle, the top view. The top view, if I have projection of this, is a rectangle. That's the top view of this. Front, top, and what about the lateral? Or the rectangle? Or the rectangle here? Nice, no? And of course, because it's circle, I am going to mark with center lines, indicating that it's circle. Those are the 3 orthographic projections, top, front, and lateral of this object. Nice, no? Okay, we are going to change the object, and we are going to play a little with the imagination. And suppose that I have this object. the object, and we are going to check that object. This is the front, this is the top, and this is the lateral. Okay, that's the front, that's the lateral, and that's the top view. You have the paper in your hands. We are going to try to do the orthographic projections about that element. But pay attention. To do the projections, we are going to mark those planes in different colors. That one green, this one blue, this one red, and for example, purple, this one, purple color, and for example, pink, pink. Okay, with your pencil, try to do the 3 orthographic projections of that object in your paper, and I want to see your advance. Okay guys, we are going to check what happened in the front view. What happened with the front view of this object?
Rectangle.
It's like this, no? It's like this. And what about the green surface on top? In front.
We can see it.
In front is a line, because you are in front. It's a line, green line. What about the red side? The red side is a red line in this side. What about the blue one here? The blue one is here. What about the purple? Where is located the purple? That one, this one, this one. It's here, no?
Yeah.
It's here. And what about the pink? What about the pink?
Where?
The pink is this, no? That one. Yes or not?
Yes.
Okay, this is the front view. Oh, it's a little in class. Okay, what about the top view? The top view is, what about the green area on top? Is solid on top, no? Is this? What about the blue area on top? What about this, the pink? The pink is a line here, no? And after that we have the blue one. And in the bottom we have the purple. This is purple, and this is blue one. Yes or not?
Yeah, correct.
This is the top. This is the top view. What about the lateral view? I make the projection of the lateral view. Is like
L.
is like this. What color is this?
Red.
It's red, no? What about this line? What color is?
Green.
It's green. What about this line? What color is?
Blue.
Ah, nice, no? Those are the lateral views. I have a question. What happens if I make a hole? Look, I am going to modify this picture a little. I am going to make a section here. That section. And I am going to do a hole in the middle. Ah, nice. Nice, no? In what view, front, top, or lateral, I can see the hole, the drill, solid, complete. On top. On top, in this area, I have the circle, and I am going to mark with center lines. What about that hole in front? What about that hole in front? Is invisible. Where? Where? In that area, no? Oh, okay, look at this. That hole here is like this. I have the projections. I have dot lines here. And I have the center line indicated that the hole is over there. What about that hole in the lateral? Is solid? Is invisible?
Yes.
Oh, it's exactly the same, no? Nice, no? Where can I see that corner solid?
Front.
In front view. In front view, I have that corner completely solid. What about that corner on top?
You can see it.
Excuse me?
You can see it.
Nothing?
No, you can see it from the top. You can see it.
But you can see something. For example, suppose that this is the color here, and this is the color black here. What happened on top?
You can see the red.
I see one line completely black, and what about the red dots? Are here, no? Yes or not? What about that corner in the lateral? The black is here, and the red is here, no? The red is here, and this is black. Yes or not?
Yes.
You like it? Difficult? Those are orthographic projections. It's like if you have, it's exactly the same like if you have this object inside of a cube, no? Transparent, and you have the projections in each side of that box, crystal box. If I disassembly the box, I have the projections in each face. You understand? Front, top, lateral, other lateral, bottom, top, right side lateral, left side, and front and back. That's okay? Nice, no? Let me try to change for other objects. We are going to do the projection for this object. Okay, the picture is this. All right. This is the object. We have a new student. Welcome to the cordon bleu.
Good.
You want to read the share?
Lateral view, front and top. Great, no? Okay, we are going to do, look at this. This is exactly the same like if I have a division of, if I have the box open, and suppose that this is 45 degrees, we are going to pass the dimensions equal in all the box. I am going to explain right now what is the meaning of that. Okay, what is the front view? The front view is something like this. Yes or no? It's okay?
With a hole in it.
With the hole, no? The hole is in the middle. The hole is solid in the middle. Ready? Great. Okay, what happened with the top view of that object? It's something like this. And what about this area on top? How you see that area on top? It's a rectangle. It's a rectangle. And what about the hole in the middle? The hole in the middle is invisible with dot lines, no? With center line indicating that you have a hole over there. You have a drill. Yeah, it's clear, my friends?
Mm-hmm.
What about, look at this. I am going to do the projection of this here, 45 degrees, and I am going to bring those dimensions in order to create exactly the same picture on the lateral. And what about the hole? The hole will be invisible lines. That's the projection. That's clear? This is the object. This is the lateral view. This is the front view. This is the top view. And this is the object. We are going to make a modification on that element. We are going to modify that object with that small section. Where you see that section full, solid, on top, no? In that point. Yeah? What about with that section in the front view? Invisible? In front is invisible? It's two lines, no? It's one line here and other line here. Yes or not?
Yes.
And what about on the lateral?
Invisible.
It's invisible. It's here, look. I do the projection here, and it's here invisible. Everybody follow me? Nice, no? My friends, in this business, in the marine business, you are marine engineers. You need to make drawings every day to explain to the customer, hey, my friend, the shaft is broken behind in the other side of the transmission, and this is the situation, and you need to explain to him with a picture. I am going to remove the coupling, I am going to separate the transmission, and I am going to replace the motor mount, and this is the motor mount. You need to make pictures all the day. And also, you need to create the picture, design the 3 orthographic projections and the isometric. This is the name of this element, isometric. Right now I am going to explain the procedure to make that drawing, the isometric. You have the picture of the isometric. The isometric is in 3 dimensions, and the orthographic projection are in 2 dimensions. Those 2 dimensions, and this is 3 dimensions. You do the drawing, and you send to the machine shop. And the machine shop, with this information and the measurements, now I am going to explain the procedure to add the measurements, they fabricate in the material that you prefer that element. You need that bracket, that support, to install the steering cylinder. That's the bracket. You created the drawing, the technical drawing. You send to the machine shop, and they fabricate the drawing with your information. This is very important for you. What is the secret of my books?
Drawings.
My pictures. Because my pictures are better than my language. That's true. You need good technical picture. You are engineers. My friend, enter in internet, check about orthographic projections, and practice, and practice, and practice. Okay, great. We are going to do another example. This picture is too simple. Nice, huh? That's the picture that you have in your paper. That's the front view, that's the top, and this is the lateral view. Lateral or right side or left side, exactly the same. Okay, we are going to do the divisions for front, for top, and for lateral. Okay, great. What about the front view? It's like this. Like this. That's correct?
Yes.
This is the front view. And what about that drill?
Visible.
Invisible in front? Invisible in front?
Invisible in front.
It's here, no? It's here. And I mark with a center line indicating that it's circle. Great? Ah, nice. What about on top? That's the projection. Okay. What element, what part of this drawing is solid on top? You can see solid.
Drill.
The hole. The hole in the middle. The hole here is completely solid with center lines indicating that it's circle. Right? What about this section over there? Is invisible. Look. It's here and it's here. Let me try to do the drawing in the lateral side. I pass the projection over there. projection over there, and now I have the dimensions of the lateral side. Okay, what about this section in the lateral side? This one here is completely high, is invisible. What about the hole here?
Invisible.
I bring the is here, is invisible with the dot lines. And the center indicating that is circle. This is the lateral view, the front view, and the top view of that object. Suppose that this object have, this is a bracket, and the bracket have that section only over there. Where can I see that section solid? In the lateral, I have this section solid. I have a question. Is like this in the lateral, or is like this?
Like this.
It's like this?
No, oh, okay.
Excuse me, it's like this if you have the same in both sides.
Yeah.
Here and in the other.
Yeah.
If you have that section only in this side,
You will have a line.
it's like this. That's clear? Nice, no? What about that section here?
Invisible.
What about that section here?
Invisible. With line.
You see? You like it, guys? Okay, guys. We are going to do the picture for this isometric. Okay, this is the isometric. This is the isometric, no? Okay, once again. All right. Front view, I want to see your front view. Yeah, the colors are very important. Okay, this is the top view, the front view. It's okay? What about the top?
It's a square.
Is a square. It's a square like this. And what about this section on top? You do the projection here, and you do the projection here, and now this is invisible lines on top. And how I know that it's a circle?
You have to do the center line.
You do the center line here, indicating that is circle. Nice, no? Okay. Let me do the projection here, 45 degrees, and I pass the dimensions. And I pass the dimension here, and now I have This is the lateral view. This is the lateral view. And what about the section, this section in the lateral?
Invisible.
On the top view, how do we know that it's not just a hole in the middle? And one of these?
No, because in front you have another
Yeah.
center line
Yeah.
indicating that is half. For that reason, you need other view.
Yeah.
In some cases, you say no. This is a good question. In some cases, you say no. It's more representative for my picture, the lateral of this side, not that one. Or the bottom view, not the top, because you have a drill in the bottom. Yeah? That depends. Okay, what about this one over there? What about this? Is
Invisible.
invisible. And you have
Center line.
center line, but because it's circle, the center line is,
On the bottom.
yeah, is in the bottom. That's clear, my friends? Pay attention. Suppose that I have here a drill. Where can I see solid that hole?
On top.
On top, here is the circle. What about that drill here?
Invisible.
And what about that drill over there? Now it's complete my picture. My friend, remember, this is the difference between a technician and an engineer. The engineer makes drawings. The engineer creates drawings for the machine shop. With the last one, I want to create the isometric. Let me explain something about that. You have the new picture. This is the new picture. Try to do the orthographic projection of that picture. And I am going to explain the procedure to create the isometric when you have the views. You have the views, and we are going to create the isometric. That's okay? Okay. We are going to create the views. What is the front view of that object?
Rectangle.
It's a rectangle. It's a rectangle with a hole in the middle, no? And that's it? The front view, that's it?
No, you have a invisible line.
You have two invisible lines, no? One here and other here. And what about the top view? The top view. Where is the invisible line in top view?
Gonna be two then.
Here or here? Where is the invisible line on top? In the bottom or on top? Bottom? Yes,
On the bottom.
it's in the bottom. What about the circle?
Gonna be on.
On top.
On the bottom as well.
Invisible.
On the bottom.
Invisible here. Invisible here. With center line here indicating that you have a drill over there. Now, the top view is complete?
No.
Finished? What about the lateral view? What about the lateral view? The lateral view is it's like this. It's a rectangle.
No.
It's a rectangle. It's a simple rectangle.
No.
No.
They're missing.
There's gonna be
You're
lines.
missing the right side.
Lines and a hole. It's gonna be a hole as well.
It's a rectangle.
No.
No. How
It's
is
a C.
It's like a C. It's like a C.
See.
That's correct.
There.
What about the drill?
Invisible.
You blow someone's earrings with it.
Ready? Ready? Nice, no? Okay. Suppose that I don't have I only have the views and I want to create the solid, the isometric. The isometric is the 3-dimension projection of the object. And the orthographic projections are the 2-dimensions projection. Okay, we are going to create the imaginary cube, like this. It's in crystal, it's transparent. And I am going to do the projections on each. And after that, I am going to create in the middle the solid. Because I do the projections and in the middle finally I have my object. I have my object in the middle. The solid. That's clear? I have the views and the projection in the middle is the isometric. Normally this is 30 degrees or 45 degrees depending. Difficult? A little? No, it's practice. It's practice. In internet you find a lot of pictures about orthographic projections and objects. And you need practice and practice and practice and practice. This is the first technical course when you study mechanical engineering. In the first semester, you take one course of introduction to engineering, and the second course is this, technical drawing. And this is a small part of that big course. I teach that course for 20 years. I love it, the technical picture. It's in my opinion the most important for engineers, because the engineers talk with pictures, with drawings, with schematics, with the diagrams, with wiring diagrams. If you try to transmit your idea with a good picture, you are a good engineer. Yes or no? Okay. Now we are going to talk about the dimensions, how to create the technical drawing with dimensions to send to the machine shop to create the piece in metal, in wood, yeah, in plastic, in fiberglass. I have an example. We are going to try to do that example. Okay, we are going to do a simple isometric like this, for example. You have that picture in your paper. In the second picture that we did, probably.
Magic, right? Where they put their money.
this is the picture, and we are going to do the blueprint in order to send to the machine shop to fabricate that piece. Okay, normally it's in a paper. And we are going to create the 3 views here. Okay, and in the front view we have this the front view of that solid. Yes or no?
Yes.
And on top we have this situation. With the drill, and in the lateral we have this situation, and we have this. That's correct?
Yeah.
Yes.
This is the lateral view, that's the front view, that's the top view, and this is the isometric corresponding to that picture. Okay, and now we are going to identify the name of that picture is air conditioned bracket. Okay, and the material is in steel 316, and this is by Lopez. All right, and today is October 26. That's correct, and the dimensions is standard in inches. The dimensions. That's correct. All right. We are going to do the dimensions. In what view can the dimensions normally are in the orthographic projections. Never try to put dimensions in the isometric. The isometric is only to show the shape of the object. The dimensions are in the views. Okay, in what view can you demonstrate this dimension?
From you.
In the front view. In the front view, we are going to extend the lines, and we are going to indicate that is 2 3/4 inches. That's correct? Where can I indicate this thickness?
Lateral.
Lateral or front? In both of them, no? I can indicate here, I extend here, (1.0 inches. Where can I indicate this distance? In top or in the lateral? No? Right? Where can I indicate the diameter of the drill? in front. That's correct? Look at the indication. It's with the arrow indicating the center of the circle. And how I know if the circle is in the center or is is off a little?
Do the same, the extension.
I can indicate that it's here in the center. What is the meaning of 2 3/4? I don't remember, but it's 1 7/16, something like this. Okay, indicating that it's in that dimension. Okay, what about this one? Where can I indicate this element?
Top.
In top or in front? Okay, on top I can indicate this one. 1.0, and this one 1.5. That's correct. Where can I indicate the thickness of this? This one, that thickness, in the lateral. And also this distance probably on the lateral, no? You like it, guys? Looks professional, no?
Yeah.
You can send to the machine shop, and the guy of the machine shop, they fabricate in the material. What material? Oh, it's steel. You need another indication? Good, no?